Thank you. Is this thing on? Can you guys hear me? Okay, great. Well, it's wonderful to be here, so thank you for the introduction. My name is Karel Dooslink. I'm a PhD researcher, PhD student at Stanford University, where I'm advised by Professor Chris Potts, and also at Ghent University in Belgium. I'm here on behalf of a couple of different organizations, so the Stanford Natural Language Processing Group, the kind of umbrella organization, the Stanford Artificial Intelligence Lab, or SAIL, Stanford Dawn, which focuses on training scalable and building scalable AI systems, and then a very new group, the Center for Research on Foundation Models. So we've already had a really interesting day. Like I really like Julia's talk about like the text analysis, and I think she made a very good point about how you should kind of build your institutional muscles and you kind of, go through this process. So my talk kind of really fits perfectly on top of her talk. And Patricio suggested a title, large language models and disruptions of the banking industry. And I'm really flattered because it suggests, that I'm going to tell you how the banking industry is going to be disrupted. I think in terms of banking, you guys are the experts, right? So we were thinking about, maybe a slightly more academic title like GPT-4 and Beyond, key concepts for these models and impact on the banking industry. And while we were discussing this, AI is a fast-moving field. This title is already outdated, right? Since a week ago, it's GPT-4. So I'm basically having to update my slides as we speak here to follow the field of AI. Now, just one slide on me. What do I work on? We've already touched upon something that's very important in AI, and that's explainable AI, right? You don't want to be deploying these very big AI models without actually some governance, without like figuring out what they're doing. That could go horribly wrong, and I would advise against that, right? So that's something I've been working on with the people at Stanford last year. And then Patricio also hinted towards it, like the NLP group also did like some biomedical things. So that's something I'm really focusing on now. Like how can we put these incredible tools in the hands of doctors to really accelerate how we're doing, biomedical research, for example. So that's something I'm very excited about. We live in a golden age of AI. The kind of things that happened in the last 2 years, I think not a lot of people saw them coming, right? Since I started doing my PhD, the whole field has kind of changed like every year. We now have these kind of very strong text-to-image models. You might have seen these kind of models, right? You input like a description. I want an astronaut riding a turtle on a rainbow, in space, and out comes the image, right? And this is all fun and games, but it's also kind of changing what it means to be an artist. And we as a society are figuring this stuff out, right, as we go. We have these very large language models, and these are going to be the star of our talk today. We have coding tools, right, like that can help you with your coding. So we were talking about open source, and a lot was like everything as code, and I think that's true. There's a lot of value in having a lot of things as code. But of course, one of the hard problems is that everybody in your organization needs to be a kind of mini developer. Well, how can these kind of systems supplement this? Cancel. And then, of course, we're also seeing like search technologies being disrupted as we speak with these large language models. So there's just a lot of stuff happening. I have no clue where we will be in 2 years, but I did not foresee this 2 years ago. So I already hinted at this. GPT-4 arrived last week. It's already making an impact in the kind of banking financial sector, right? There was this report about Morgan Stanley, where it said that Morgan Stanley Wealth Management deploys GPT-4 to organize its vast knowledge base. So there's this report, and from the report we can deduce that they're using these models to summarize, to search, to generate answers. We don't exactly know how they're using this, so they're not very transparent about this. I really hope, I'm an advocate for like open source and open source science, so I hope, a lot of the organizations that use this technology are more transparent about it. But for example, I did a kind of test myself, right? So I went to GPT-4 and I said, so I'm originally Belgian. Belgian taxes are, quite the hassle. So I said, okay, from now on, you're a Belgian tax expert and you specialize in helping PhD students with their taxes, right? Just something I wrote down in 10 seconds. Then I said can you help me with my taxes? And, the result is very convincing, very fluent. It says, of course, I'd like to help you with your taxes. And actually starts with asking me like 5 questions. Like, are you a Belgian resident or not, right? And this is kind of exceptional that this just worked, right? I just took something off the shelf. I said, you're a Belgian tax expert, kind of help me. And the kind of, initial results that we're seeing for me doing 1 minute of work, kind of insane. And you can do a lot of things with these, right? You can for example, you could say, well, you're a Shakespearean pirate, right? And your primary goal is, to recruit a crew for a next adventure. Can you help me with my taxes? I'm not sure if in Santander you have a business case for pirates taxes, but, and actually this model, right, with the same kind of question, it says like, okay, sure, I'm a pirate, right? And it really generates this nice, convincing, fluent piece of text where it says like, why care about taxes? Join me on my next adventure, right? And this is all fun and games, right? But actually, the stakes for AI have never been higher. So this has led to some amusing and also, slightly worrying and disturbing stories in the news. For example, a headline from February the 8th, right? Google's Bard AI bot made some mistakes and the market reacted. That wiped 100 billion of value off the shares. Same day, Microsoft stock prices go up because they're challenging Google in this race for AI in search, right? So we see these big tech giants, right? Google has been like dominant in search for like 10, 12, just like the last decade. And now we're seeing like really these tech giants like scramble to get the most value out of this new technology. Okay, so that's the kind of setting. Now we're gonna dive a little bit deeper into like the performance increases we've seen in the last years for language models. Consider the question, which US states border no US states? It's just a simple question maybe. Well, in the 1980s, we were already trying to build these well, not me, I wasn't born, but in the 1980s, we were trying to build these kind of AI systems, right? And we would this is a famous Chat 80 system, we would hand code a lot of these rules, right? And this can do amazing things. This can answer which country bordering the Mediterranean borders a country that is bordered by a country whose population exceeds the population of India. The answer is Turkey, and if you knew that, well, that's really cool. I was not able to answer this question, right? However, with our question, it just kind of fails. It just doesn't understand it. It doesn't know what to do. It just says, I don't understand. It was not explicitly programmed to do this. So fast forward 30 years to the Wolfram Alpha search engine, and we ask it our same kind of question. We don't actually get a good response, but it just at least knows we want, a kind of answer that is a US state, so it just gives us all US states, right? Valiant attempt, but if you think about this in terms of 30 years of research, the kind of gap we're seeing is maybe, a bit disappointing. Fast forward again 10 years to the first of the current era of AI models. This is the ADA model, and when we ask it our question, it just says, nope. And then it starts to babble a bit, and this is really kind of concerning, right? If we were looking at this in 2020, we would be really worried about whether or not these models could actually do the complex kind of tasks we're talking about now. Same year, slightly more advanced model, nonsensical answer, right? 2021, Curie model, slightly more advanced, Alaska, Hawaii, and Puerto Rico. Great attempt. Puerto Rico is not a state, but still, already is seeing some signal. 1 year further, we have a Da Vinci Instruct beta model. I'm going to go more into detail what instruction means in terms of these models. It says Alaska and Hawaii. So in terms of 2 years, we've made more progress on these kind of challenges than, since the 1980s. And that's really the kind of rapid advancements I'm talking about. And then now one of the best-in-class models says Alaska and Hawaii are the only US states that border no US states. Very fluent, very factual, correct. Amazing development that happened in the last 2 years. Now, you might say that this kind of question is, somewhat a simple question. A Google search could solve this question as well, right? So we can go even further. Would it be possible to hire a team of tamarin monkeys to help me paint my house? Assuming I'm willing to pay them in sufficient quantities of fruits to meet minimum wage requirements in California. And so you're all laughing, right? This for us, it's okay, everybody in the room kind of knows the answer. But actually, this is a really difficult question with a lot of distracting information. And even a lot of good models say, yeah, sure. You can hire a team of monkeys, if you give them enough fruit and you get minimum wage, that's fine. But actually, we're kind of seeing that the latest models are also saying like, well, no, these are wild animals. You can't actually hire wild animals, right? So, this was a funny example, but actually what we did here was a Turing test. We did a tiny little Turing test here, right, to kind of actually start to figure out like how smart are these models. And if you're a film buff, you might kind of think about the movie like Blade Runner. Great movie. There's a lot of these interrogation scenes, right, where they try to figure out, is somebody I'm talking with, is that a human or is that a robot? And they ask a lot of these like Tamarin-like questions that models seem to struggle with. And actually, we've kind of wandered into this futuristic era where if you're emailing with somebody or like if you're reading something online or you're having a conversation, it's not directly clear anymore whether or not that's a human producing a text or that's been outputted by a large language model. And this has, of course, incredible implications on things like misinformation or phishing attacks, right? So this is something we should be aware of, and we should really think as a society how we deal with this. Okay, so I've kind of sketched where we are at now. I want to take a few moments to talk about what drives performance. So this is a highly technical field. I'm just going to try to give some intuitions as to very high level how these things are operating. This will be relevant later once we start talking about like how can a company like Santander actually start using these technologies in, for example, the call center application. One thing that's really interesting is self-supervision. The kind of main objective of these models is to learn co-occurrence patterns in the sequences it is trained on. So we already talked about like unstructured text. You have a lot of articles, you have a lot of reports, you have policy documents, right? These models just go through all this and they kind of, try to pick up on patterns, right? And then what I just showed you, this kind of generation, that's this kind of secondary process where we sample from the model. So we're going to do that later, right? But so like better late than never, the model has kind of learned that that's just more probable than the sentence better late than pizza, right? Because it kind of, I'm simplifying here, but I kind of saw that better late than never just occurs more. And then there's a other part of the puzzle, which is that this model is trained on sequences of not only language. These sequences can contain anything. Different languages mixed together, code, metadata, sensor readings. Like we're training these models really at internet scale. They're seeing, more information than a single human would ever see in their lifetime. And this contains like just all kinds of data, right? And the fact that we can learn from this unstructured data, which is freely available on the internet, meant that we could unlock another thing, and that's model size. So here we have a graph starting in 2018. In AI kind of history, 2018 is previous era. That's really a long time ago, right? And on the y-axis, you have like millions of parameters, which is a kind of shows you how large these models are. When the first kind of models came out, early 2018, 2019, they had like 100, 200, 300 million parameters. And we researchers were already like, that's a lot of parameters. Well, it just kind of kept increasing up to a point that it almost seemed like a joke. And indeed, with GPT-3, we're at 175 billion parameters. This is not something you can run on your laptop anymore. You need like a kind of supercomputer to do this, right? And actually, it just kind of kept increasing. So now we're at like a Palm model, which has like 500 billion of parameters. This is a model developed by Google. And actually, you will see that all of these models are kind of developed by some tech giants: OpenAI, Google, NVIDIA, Meta, Microsoft. And we'll get to this later, what kind of implications this has on the ecosystem. But really, this kind of size has shot up and performance has really followed. Then that increasing performance has enabled us to do something else, which is prompting. When you prompt a language model, you're kind of putting it in a temporary state and then you're generating a sample from it. So imagine my like pirate example. I give it like a prompt, you're a pirate, and it just rolls with it. And it's incredibly, incredibly powerful that we can start designing these systems by just telling them instructions in English, where previously we would need a whole team, get a whole lot of data and like develop new systems. So when we ask better late than, the model knows never because that's just an idiom, right? That's like a property of our language. If we say every day I eat breakfast, lunch, and dinner, the model is like, yeah, sure, I read a lot of text where that's expressed. I kind of understand this. If we say the president of the United States is, we hope to get something like Joe Biden. But I want to stress, like, the model was never explicitly thought like, hey, the president of the United States is now Joe Biden. This is just something it learned in the same way that it learned better late than never. So, and this is really important when you interact with these AI systems. If you say the key to happiness is, right, and it gives you an answer, you shouldn't expect some deep philosophical reasoning about the world. For the model, this is all just kind of the same mechanism. So we as humans tend to think that if something like, sounds like a human and it says something like the key to happiness is this, or like I'm sentient, that's actually true. That's not true. That the models are sentient, and the key to happiness, well, you have to figure that out for yourself. Right, I'm gonna quickly jump over this in the interest of time. Then another thing, right, and we're getting towards the end of these more technical concepts, is learning from human feedback. So actually, this last year, we kind of, self-supervision used to really be, all there is to it. Now we're kind of moving in a new field. We're figuring out how can we optimally use human experts to kind of teach these models things. And that's actually really interesting because previously AI kind of worked on structured data or like labeled data where you get a lot of humans to, look at pictures of cats and dogs and say, this is a cat, this is a dog, and then the model learns from this. Now, to teach these models new skills, you really need to be an expert. Like, people are making whole presentations. People are writing whole chapters of a book and writing whole Python programs and explaining how they're doing it and then inputting this into the model to make them even better. All right, one last concept, and then we can go towards something that's a bit more relevant for like the business side of things. That's step-by-step reasoning and chain of thought reasoning. So these are also like really new innovations, like a year old, that really, helped push these models forward. So if we ask like a question like, does a model know that if a customer doesn't have any loans, then the customer doesn't have any auto loans? This is a simple reasoning challenge, right? And you want to make sure that models, are able to do this before you let them, aid your lawyers, right? And this is the old school prompting style, right? Where we just give this question to the model. And, this is so 2021. Ages ago, really, the model says, no, it's not necessarily true. A customer can have auto loans without having any other loans. Clearly, yeah, just not an answer to our question. And it also, was very confident, right? So we already talked about this. It's really confidently incorrect here. And you don't want somebody like that in your organization, I guess. What we've kind of learned now is just by changing how we ask the question, we can get much better performance. So we start, and personally, I think this is hilarious. We start by saying the model, you're at an exam. You're at a logical and common sense reasoning exam, so you better try your best, right? We give it some instructions, like, we're going to ask you to explain your reasoning, then you're going to answer yes or no. Then we give it like some formatting, right? And then we ask the question. So actually, if we do this, right, about the auto loan things, it actually outputs, what we could say is its reasoning, and then it actually correctly says yes. So what I kind of want to illustrate here is that instead of designing a whole new system, instead of getting new data, instead of like doing all the hard work, we kind of figured out like, okay, we just interact with this model differently and we get this kind of different behavior. That's like the same as with the pirate example. We just figure out, we rapidly prototype what works and we see what performs well. Okay. My ultimate goal today is really to give you all the basic, fundamental building blocks you need to start thinking about how will this impact my industry. Before we do that, I just want to sketch like the global current landscape of the players in this large language model world. So the focus in this world is on big models. The kind of really hope, the kind of hope of the community is that we can make these really, really, really big general models that you can then easily deploy to a lot of different use cases very flexibly and very performant. Remember this slide, right? The size has been gone up. And I've noticed already these big tech giants, and this was really a concern. So previously, we had all these tech giants being the only ones that could even develop this because it costs so much money to build such an AI system. And my professor, Chris, a couple of years ago, was actually at a workshop at Stanford where there were representatives from OpenAI. And really the primary concern was like, is this not a centralization of power? Like what happens if only a few people have access to this really, really powerful AI technologies? And something that I'm really happy to report on is we think that this is changing. So a recent effort by Stanford was the kind of Helm evaluation, was to kind of take a lot of different language models and uniformly evaluate them so that we can do better research. And actually, we've been seeing that there were many more players in the large language model field than a few years ago. So we, of course, still have the big tech companies, but we also have loose collectives. For example, Eleuther AI and Big Science is just a bunch of researchers really getting together and in a kind of very open source science thing, just transparently trying to build these technologies and open sourcing them for everyone. We have one academic institution here, Tsinghua University. We'd like to see more academic institutions here, and that's a work in progress. But also importantly, we're seeing a lot of startups that are really contributing to this field, sometimes also just open sourcing their models, right? And all of these models are performing really quite well, I'd say. And tomorrow we have a talk about Mosaic ML. These people specialize in driving down the costs of developing this. So, I as a researcher, I'm really, really excited about the fact that, this ecosystem is widening. We're seeing it get more open, and we think that this will kind of accelerate the kind of business impact and the amount of research that we're able to do. And on top of these models, one more thing, the sizes also have been going down due to like technological innovation, and it means that things that you would previously need a supercomputer for, you might be able to run on your company cluster or, on your research cluster. So that's, tremendously exciting. The Stanford Alpaca model is one of the best in class smaller models now, also released 2 weeks ago, right? So a lot of the information in these slides are really, really recent. I just want to show a bunch of startups starting to build on top of this technology. I feel like it's almost annoying at this point. I cannot open LinkedIn or Twitter anymore, without like just seeing 50 new, like, oh, we're going to use LMs here, we're going to use LMs there. Not all of these startups will succeed, but it's really exciting to really see what people are doing with this technology. This is causing some changes in the labor markets, and I want to reflect on this because I think this impacts all of us, and we should think about this. As some of you might have children that are, in college or in high school, and they know that, the fact of writing has kind of changed to being an editor, right? I think these models produce very, very, very good text, but, so less focus on producing the text, more focus is on making sure, does the text make sense? The same for people maybe, that are transcribing, phone call recordings. We're letting AI do this transcription really fast, in some cases really well, and the person is more like a kind of supervisor that needs to make sure that, all the kind of errors are handled. A programmer. I'm a programmer. That's kind of changing to being more of a software designer and a tester. I've experienced this firsthand. A lot of my colleagues are like saying that for like mundane things like formatting some data or like creating some graphs, they're just using ChatGPT, and then they're just checking whether or not it works right. Data scientist. I'm also a data scientist. I hinted at this. Like the formatting of the data, which is a lot of the mundane day-to-day work of a data scientist. These models are starting to do this in some sense. So the focus becomes more about like, okay, more science. What do you decide to do? What kind of approaches will you test, right? A photographer, I hinted at this in the beginning. the fact that some of these models are like giving you photorealistic images to accompany your text, what does that mean for like the creative space or the photography space? Assistant, like things like scheduling become more about relation management, crowd working. I'm not going to go too much into detail here, but the kind of, yeah, I wish I had like a good prediction here about the next 2 years, but I have no clue, I think, what my job will look like in 2 years. I'm doing a lot of programming, I'm doing a lot of writing, I'm doing a lot of research. I think all of these aspects, we're already seeing them being, you know, kind of disrupted via these models. So definitely the day-to-day is changing. It's not clear whether skill levels will increase or decrease. I think, like, you know, if you're spending less time programming and more time designing systems, I actually think that designing the systems is more challenging and you need a lot of human input there. But it's not clear how the labor markets are fully going to react to this. And, you know, labor markets is one thing, industries is another. So there's a lot of potential to help humans in complex workflows. And now we're going to start to make our way towards the kind of goal, which is give you some insights into how language models could help in your business. So you have some data. We already did a lot of talking about data, right? You can have structured data, but you also can have unstructured data, right? Just like piles of documents just lying somewhere. I think like 5 years ago, people would say like, oh, invest in structuring this, invest in cleaning this up. That's still true. Everything starts with the data. But, you know, if it's just like, you know, a 100-page PDF, that's fine. You don't need to like clean that up and like put it in an Excel sheet, I'd say. Then you have customers, right? Internal customers that want to know something, or external customers like in a call center. And you put some kind of layer in between, like for example, a call center. And that's really like a skill job, right? These people need to access the data, but they also need to be good with customers. And increasingly, I think we're going to see these people be augmented with these kind of language modeling capabilities. So for customer service, the language model can help you retrieve, synthesize, and summarize in plain language. I'm not advocating here to just let, you know, the language model fully respond to a customer yet. That might go horribly wrong, but in terms of like helping somebody respond to a customer, or like giving the initial draft to respond to a customer, right? Or just helping you search over all the documents that you have. I think these techniques can be very, you know, very productive when applied today. Insurance, you know, answering questions about very long, messy, complicated documents. Healthcare and life sciences, you know, assessing risk, suggesting treatment plans, building clinical trials, research and discovery, emerging trends, forecasting, new questions. So I think we're really not sure how far this is going to disrupt a lot of these industries, but I think a lot of players, like, you know, the example I showed in the beginning, are really trying to use this technology now to get value. So the final part, I just need to check my time, right? The final part today is really some key concepts, how you can use these large language models in terms of deploying them and in terms of using them, right? What might such a deployment look like? On the one hand, we have a kind of approach that's kind of the mainstream approach now, which is the large language model for everything approach. And I'm going to advise against this, right? So what you do is you take a large language model, you give it access to all your data, it learns from all your data, right? And then you're going to give your call center, you know, access to it. And you're going to ask things like, oh, you know, draft me an email, or, you know, what was the stock price yesterday? And the language model is just going to output all of these things. And the kind of key concept here is that the language capability, but also the knowledge that your language model has about your business, is fused together in one really big model. Now, something that we're seeing in research, and that we think a lot of people are catching onto, is kind of retrieval augmented language models. And it has a kind of different architecture. So you have your data on one hand, and you let your language model, technical term via a vector similarity index, just ignore this, you're going to let your language model search through this data when it has to do something. So, you know, you could ask your language model, oh, you know, draft me, you know, an email to the CTO about the latest developments and you know, how many, I don't know, how many bugs did we have in our code last week or something. then the model will actually go to all your documents, like find the relevant documents itself, much like how you go to Google when you want to do something, pull out the interesting information and kind of then write that email. And so regardless of what kind of deployment you kind of choose from, there are a few key concepts here. That's synthesis and fluency, right? You want like good sounding text that makes sense. You want updatability, which means that if your organization is changing, if policies are changing, if you get new customers, your model should be able to fluently adapt to these new environments without you having to do a lot of work. Provenance or factualness, really important. You want to know like where does the information come from? If my model said this and that, like, can I check this? Like, especially in like regulated environments, like where does this information come from? And then last, but definitely not least, safety and security, right? So the first thing, fluency, we give it a cowboy emoji, very, we're scientists here, to just indicate that, these models are doing this really well. So we'll start with updatability. Sorry, efficiency. I'll go into updatability. Yeah, so in the kind of language model for everything approach, facts are hard to update. There are models today that if you go and you ask them who's the president of the United States, they confidently tell you Donald Trump is the president. These models maybe do not believe in like conspiracy theories or something. It's just because this model was developed when this fact was true. And it's really hard to update these facts. But if you have like a kind of like retrieval augmented large language model, you can just change your data on the fly because your model is always grabbing back to your data to like generate things. If if a policy document is changing, or maybe, we have a new president, you kind of update Wikipedia or you update like your policy database, and that kind of, the model just starts working with this new information on the fly. So we're really excited about this from a perspective of updatability. Factualness. Large language models for everything. Return to the question about the tamarins, right? I said, wow, that's really interesting that you know all this stuff about tamarins. Like, which web pages can back you up? So the model says like, oh, no problem. I'll give you 3 URLs. And I think, oh, great. None of these work. It just kind of fabricated, hallucinated some URLs. And it's like, oh, yeah, Carl, he'll be fine. He'll not. Oh. Right. So indeed, like totally bullshit where this information comes from. In terms of these like retrieval augmented models, right, they find the kind of documents that are interested for them, and then they will summarize information from there. And that really makes it that, you could actually start putting links and saying like, okay, we actually think with a high, high probability that actually that fact originated from that document. So it's like more auditable. And we're extremely excited about this as well. Then safety and security as a kind of last thing. I think as a bank, this is like, top of the priorities. And there's a lot of challenges with the large language model for everything approach. For example, user privacy. These models are known to memorize long strings from their training data. The last thing you'd want is that the model starts exposing addresses or like bank account information. That would just be horrible. You could never put something that could even do this remotely into production. In terms of like the client security, if you have like multiple clients, multiple tenants, it's really hard to compartmentalize the kind of information in the language model. And even at the organizational level, maybe you have like different levels of like security clearances or things. You cannot say to a language model, like you're not supposed to, say this fact to that kind of person. That just doesn't work. In the kind of retrieval augmented language models, this is already a solved problem. We're doing this every day, right? Like you have data in your company. Not everybody gets to access all data, right? You have already systems in place. So just apply these systems to the language model, right? Maybe if it's dealing a request of one client, block off all the personal data of other clients. And so it's definitely not a completely solved problem, right? But we think that these retrieval augmented language models can really do it much better than I think what we're seeing in the current wave of how these models are deployed. Okay, I want to just reflect on what we've been talking about, right? So I tried to give like some insights into how is this field of AI moving. I try to give some insights into, some of the concepts behind them, like self-supervision, prompting. We saw a bit how they can change labor markets and how we think they might impact industries. Then, really practically, I gave you like some advice that we learned during research. Do these kind of like retrieval augmented approaches. They might be much more safe. Can we do even better? And this is a really, I'd say, almost like insider-like information. This is research that's only a couple of months old, right? When you solve a problem, right, you don't only go towards Google to find information. You go towards Google, you read a book, you use a calculator, you ask a friend, you do all kinds of complicated things, right? So why not start doing this with language models? So don't mind the code, but we have this, we're building this kind of framework where that's fine. Yeah, where where you as a developer can you're actually going back to programming. You're going back to these 1980 type systems, but instead of programming exactly what a machine must do, you're kind of programming these very high level interactions between these AI systems. You're saying, okay, for this kind of task, you can use this calculator and you can use this API, right? And you can use this database, right? And then go nuts. And that's something that we're seeing that is just at this point, blowing all other techniques out of the water in terms of really complicated question answering. And we're so excited about this because it's just really early days, right? People are still catching on to this. I feel so little of the design space here has been explored that we're gonna see immense, further progress in terms of figuring out how we can build these models in our complicated workflows. All right. We covered a lot of ground today. We are in a period of unprecedented progress in AI. I think not a lot of people refute that claim. I always want to make predictions, but they tend to be overly tied to the past. It's really difficult to make predictions. One thing that's for sure is that there will be a lot of surprises, good and bad, in the future with these technologies. So definitely be on the lookout. We've seen that these powerful AI systems can increasingly be designed using pre-training components and this kind of notion of in-context learning. And they can be designed with language, for example, right? I just made a Shakespearean pirate, text chatbot with a few lines of English. And that's kind of really transformative. And also in code with these kind of new techniques that we're developing. The cost of developing and maintaining these systems is going down and access is broadening. You might be excited about this. You might be scared about this. And we've seen that these assistants, they have demonstrated utility. A lot of my colleagues are using this in their everyday workflow to help them read, help them write, help them code. But we've also seen that they might fail in surprising ways and they might fail very confidently. So we need to be really, really careful and aware of this. Then I said I like to make predictions. I'm not really allowed to, but I'll do it anyways. This is a kind of prediction that we thought long about, but there is a kind of near certainty at one point, I guess, of a kind of incident triggered by misuse. So think about large-scale, really convincing phishing attacks. Think about large-scale mis and disinformation. As a society, we should be really worried about this. But then my job as a researcher and your job as people looking to integrate these technologies, we can also make sure that we're going to get meaningful economic and social positives from this technology as well. So we're kind of having to figure out, but really I believe that the kind of economic and social benefits can vastly outweigh the downsides. Thank you.
Scary.